Hello students, I am here to discuss current electricity for class 10 physics. If you like this video, hit the like button and leave the comments in the comment box. Let me start this session with the topics to be discussed under the current electricity. Electricity, electric current, conventional current, electric circuit, electric potential and a potential difference, symbols used in the circuit diagram, Ohm's law, resistance and resistivity, conductance and conductivity, series and parallel combination of resistors, heating effect of current, Joule's law of heating, electric power and electric energy, electric fuse. For this session, I am going to discuss up to electric circuit. Remaining topics will also be uploaded in the next video. So we start with the electricity. All the appliances around us using in our day-to-day life are based on principle of electricity and magnetism. Electricity is one of the most important sources of energy, and it is one of the most convenient form of energy used in lights, fan, motors, radios, television, etc. The big question is, can we survive without electricity? The answer is very simple, no. All the plants and the living animals require electricity to survive. Then, what is electricity? The phenomenon associated with the charged particle at rest or in motion is called electricity. There are two types of electricity. The static electricity, which is the phenomenon associated with the charged particle when they are at a rest. The current electricity, which is to be discussed in our topic. The charged particle in motion, which is associated with a certain phenomenon that will be discussed in here. Then what is electric current? An electric current is the flow of microscopic particles called electrons flowing through the wires or conductors. So this is the metals, atoms. Here the green dot represents the electrons. So it is simply an simulation or illustration. The flow of these electrons produce the electricity or current electricity. The electrons moving through the metal wires produce electric current. Then what is electric current? The electric current is defined as the charge flowing through any section of a conductor in 1 second. Mathematically, we can write down I equal to Q by T if the rate of flow of charge is steady. The different types of current. Here we have an IT graph, the current time graph, which simply shows A, the steady current which does not vary with time, B and C, where current is varying. The change of current takes place with respect to the time. And another one, which is represented by D, is the alternating current, whose magnitude varies continuously and direction changes periodically. The SI unit of electric charge is coulomb and the SI unit of time is second. Therefore, the SI unit of electric current is coulomb per second or ampere. It is named after the French scientist André-Marie Ampere. Some points to be noted here is that the charge is always quantized. That means charge goes in packet. Q is represented here, the charge, and the number of electrons, and E the electronic charge. The charge of one electron is 1.6 into 10 to the power minus 19 coulomb. 1 coulomb is equivalent to the charge of 6.25 into 10 to the power 18 electrons. 1 coulomb in fact is very high charge, therefore charge is expressed in smaller units like millicoulomb or microcoulomb. Similarly, current is expressed in milliampere or microampere also. This is an simulation, a diagram showing the flow of the electrons. The electrons flow from negative towards the positive terminal. The question is, in which direction do the electrons flow? The electrons flow from negative terminal to the positive terminal of the cell across the conductor. Therefore, we have the conventional current. Here, when we apply an electric field, according to the electric field, the direction of the flow of the positive charge is from positive place towards the negative place. The conventional current is the current whose direction is along the direction of the motion of positive charge under the action of electric field. So conventional current due to the motion of the electron is in the direction opposite to that of the motion of the electrons. The electric current flows in the circuit from the positive terminal to negative terminal of the cell. The positive charged ball less electron and the copper ball negatively charged means more electrons. Therefore, the electrons will flow from negative towards the positive ball. But the conventional direction of current is from positive towards the negative. Then, what is electric circuit? The continuous and a closed part of electric circuit is called the electric circuit. A simple circuit consists of a cell or a battery, switch, and the load or resistance. An emitter current measuring instrument is also connected in series in the electric circuit. A voltmeter, a potential measuring instrument, is also always connected in parallel across the load or the resistance. So here is a circuit diagram. E represented here is the cell, K for key, bulb connected by wires. So when the circuit is closed, the current flows and bulb goes. Here another circuit with a resistance, load and voltmeter. So A represent here ammeter, B represents the voltmeter, R here is the load or resistance. So this is an electric circuit with the ammeter and voltmeter. So what is electric circuit? A continuous and a closed part of an electric current is called electric circuit. The types of circuit, there are two types of circuit. One is called closed circuit, another one is called open circuit. In the closed circuit, the part of the electric charge particle is completed, therefore there will be a continuous flow of the charges. So it represented by a simple diagram here. And in the open circuit, there will be no connection of the circuit, so there will be no flow of the current, therefore the key is left open and the bulb will not glow. So these are the two types of electric circuit. In the later part of the video, we will discuss the remaining topics.